So in our last segment, I milled up the legs of our cart to show you how I dimensioned lumber from a 2x12 or a 2x10. And before I went to bed last night, I went ahead and milled up the other parts that's going to consist of the frame of our frame and panel design. And what I mean by that, this is a printout of my iPad sketch, is I have these three stretches right here. These two right here are going to be structural, and they're going to go all the way around. They're going to lock the whole frame together. This one right here is just going to be a tray for me to put stuff on. So I'm only going to have those two up front. And how I made those was I have two shorts and two longs. The key difference between the two is I wanted the main one that's going to be holding a lot of the weight to be 2 inches, this one to be 1 inch. I like having different sizes for the stretchers of my furniture pieces because I think it gives it a nice aesthetic. If you have them identical, it kind of looks somewhat production made. In these pieces that I milled up, I made it a concerted effort to get as quarter sawn as I could. Now some of them, the growth rings were tight enough that they curve, that they are actually quarter sawn on front and rift sawn in back, and you can kind of tell a difference in thickness of the grain, which means that I'm going to want to use a quarter sawn side on the show side so it'll be more consistent throughout the entire piece. Of all these pieces, I made them all consistently the same depth, I guess you would say, width, but the height of them are different between the bottom layer and the top layer. And I have two longs and two shorts, and they're all oversized. But when you're milling, you're going to get these offcuts all the time. And these are perfect pieces to save because they're the tool that will alleviate a lot of your ineptness. Now, yes, in my design, these stretchers are all different heights or thicknesses, or I don't know the exact term of them, but the length between the edges are all identical. So if I only have to measure that once instead of 6 times for the front side and 4 times for either of the other sides, see, these are all the same, it would sure make a lot more sense. Why increase your chances of making an error? And that's where these kind of offcuts come in. They're thick, they'll hold their settings, they're not too fragile, so they can take some abuse. Out of these, we make our story sticks. Story sticks are an accurate way of archiving all your measurements. They date back, centuries, probably back from when we first started woodworking, because if you lay everything out on this stick, you can then transfer those lines to each one of the individual pieces. And you can do one leg on one side, the other side you can do another part, or you can do different parts on different portions of the leg. And if you want to reproduce your work, all you gotta do is go find the old story stick you built it off of. It's a great way to save what you do for reproduction purposes, along with eliminating those errors of measuring each part individually. Now the story stick I am using is about 32 inches long, but I only need 26.5 of it for the leg itself. And just like I oversized all the components, this coming off of one of those components, it is a bit oversized, which is what you want. The other thing when you're making a story stick is this is not a time for pencils. This is a time for knives, because you want the knife to be able to drop into the piece. So if I'm going to make this right here the top of my story stick, just the top of the leg, I want to score a really heavy line with my knife. That way when I'm transferring these lines over, all I have to do is drag my knife over. It's going to click into that line and I can transfer it over to another part. Now I know these lines are going to be kind of hard for the camera to pick up, so you are going to see me darken them up with pencil lines. That is only for the camera. Normally I would not be doing that one. So I will label this the top of the leg. Now in my design, I have one of the narrow pieces up top. So me, being the lazy person I am, I will actually take my measurements directly off of the piece when I'm making it. So I can come over here, I can drop my knife line right in there, bring that up, and then just bring the piece up to it. And I know that this right here is going to be the width of my piece. Really easy way to lay stuff out. That way, if you're milling stuff up and you don't have it dead on perfect to the measurements you put in your plan, it doesn't really matter that much. come back over. Now this is going to be a mortise and tenon joint, and for consistency I want to have a 1/4 inch shoulder on all my mortise and tenon joints. This little brass thing is a perfect 1/4 inch. So an easy way for me to lay those out is, once again, drop it in, hold it there, and transfer my line over. Fairly simple. This way I am not pulling out a ruler and possibly making mistakes because my eyesight sucks. So now I have a good solid line for the total width of the part that's going on, and a layout line for my mortise and for the mortise of my mortise and tenon. I also have something I can use on either my table saw or bandsaw to set up how far off of this to cut so I can get my tenon to fit my mortise. It's easy. No measuring. It's just relative marking, relative layout, relative to another piece. Now that isn't to say I'm not going to use a ruler at all. I still have to come up with the distance between this top board and the second board, so I'm going to measure that out, but all I have to do is get one measurement right here, and then I can use the other part to lay out its bottom and the size of its mortise and tenon. The other measurement I have to do is the length of the stretchers or rails or whatever you call them, both on the long one and the side short ones. Now the key thing you need to understand is the length of this is not the length of the board. That's just the distance between the tenons of our mortise and tenon joint. We have some wood that extends into the legs. Now how far into the legs is up to you. I generally like to have tenons go about 2/3 into the board for maximum strength. And this being 2.5 inches, about 1.5 inches is okay. And I tend to choose that measurement a lot because this dovetail marker that I use for a lot of my layouts, well, its thickness is a perfect 1.5 inches. So if I lay out one side, I can just really quickly go over to the other side. And it's just an average that I use quite a bit. And to do those measurements, I have to basically have a top of the stretcher, one side of the stretcher, and then for the short one, I'll go ahead and measure that out, but then I'll go ahead and measure the long one on the same leg. So I have both the short and the long on the same side of the stick. Now, using a tape measure is not the most accurate way of measuring something, but I want you to notice I'm only having to measure one time. After that one time, I'm going to transfer them all. So if I make a slight, 16th, 32nd, 64th of an inch error laying this piece out right here, it doesn't matter because that error will be the same across the entire project. And if it's the same across the project, it's not an error. So in the end, I end up with one story stick that covers all my measurements for my legs, and the other side covers all the measurements for the long and short stretchers. No real way to mess up transferring lines from here on out. Plus, now that I have the story stick with its definite top and bottom, if you remember earlier, I oversized all my leg blanks because my tools have some snipe to them. I oftentimes get a little cracking on the end as things dry. So, and there might be some imperfections on one end or the other, notch or something like that I was cutting around, that the grain might be funky. So if I want to get the perfect spot, I can now come over. See right here, I've got some offset coloring, plus the fact that there's a little split on this side, but not necessarily that side, but this is my negative side. So I can now come over here and position my leg to get the best area of my blank. It doesn't have to be in the center. It could be up here somewhere. So having something like this allows me to lay stuff out around blemishes to get the best appearing as well as functioning leg. Now when you're doing layout work, there are some things some rules you've just got to follow. The first being, you really need an accurate square. Something that you know is going to be 90 degrees, which is one reason why I really like wooden squares, because I can retrue them up really, really easy. an easy way to check it is to just mark a couple lines off of something straight. Notice it's a little bit thicker here, and it gets a tad bit thinner there. Let me do that a little bit farther up so you can see. Actually, that's pretty accurate right there. But if you had a square that wasn't accurate, there are some techniques you can use to compensate. This thing right here, no way is square whatsoever. We'll get back to that in a second. I'm going to use this end section to illustrate a point. Now, because it's bad, and it's got one unique corner right there with that discoloration. When you're laying stuff out, you always want to label one corner your reference corner, because everything is going to be relative to that corner. If I were to come over here with a slightly out of square, say that right there, and I start marking out my line. I do it the way they tell you. I mark a line out, I come over, I lay my pencil down on the old line, I mark it out, come over, lay my pencil down the old line, mark it out. I think a lot of y'all see what's happening right now. So right now, my pencil line is completely accurate. But if I do the same exact thing and keep going around in that same way, you can tell I am way off. And yes, this example is exaggerated, but that's not too far off of 90. If you're just a half a degree off, your lines will never match up. And if you're using hand tool techniques to saw this, or hand tools to saw this out, there's no way you can saw that. But if you're doing something called relative, where I come over, I mark my line, I then ask myself, if I want to mark this face, which side, this side or this side, is closest to that side? Obviously, this side's closer because you have to go across the triangle. So my reference goes closest to that reference edge, and I do my marking. So now I'm going to come back over. If I want to mark this side over here, well, which side is closest to that corner? Obviously that one. So I flip my tool so the reference is closest to that reference edge. And I put my pencil down and I mark my line. Then I come back over here. Which side is closest to my reference edge? That side. So my reference goes to closest to the reference edge. Put my pencil down and mark it. And as you will see, now the line goes all the way around consistently. Even though that is at angles, that is something I can saw. That is something that if it's only, a half a degree off, you could join it up in your piece, and yes, you might have the slightest gap, but it will still work as a solid joint. Now, if you were to do that same technique with a tool that is very accurate, well, it's just going to, you can't go wrong. Mark it. Mark it. And also you can see why I prefer knives and pencils, because I'm having to look for my pencil line, whereas a knife line I could just drag it over. Mark it. And mark it. And I now have a perfect line that can fall all the way around, so I can get a consistent shoulder on tenons or a flat face for either the top or bottom of the leg. So once you pick your reference edge, which for me is probably going to be the corner that's opposite of the one I rounded over when I was dimensioning, because this is my show corner. That's the one that's going to face out, so I put a little rounded edge on that so I can feel which is my show side, which makes this side and this side had to be perfect 90 degrees, because those are the sides that my joints are going to go on. So the first thing I like to do is mark out somewhere on the scrap piece that my mortise and tenon joints are going here and here. That way I don't screw up any. And that also makes this corner right here my reference edge, because that's the only one that's going to touch both sides where my mortise and tenon joinery is going to be. Then when I begin laying out my legs, the pieces that I'm going to be doing, using the legs story stick, whenever I find the area, I have a little bit of a gap right there, so I want to come down past that gap about a ½ inch. And luckily, that's well ahead of the blemish right there. So once I got my location that I like, I'll use a little bit of blue tape to anchor it. That way there's less chance that I accidentally shift it. And from there, I just lay it out. I can place my lifeline, transfer it over, and make a nick in that corner. Place it in my knife, transfer it down, make a nick, place it in the knife line, transfer it down, make a nick. And then I will put pencil for the mortise and tenon joint. So there's the top of my leg, there's my mortise and tenon joint. Come down. Here, all I'm going to do is make a nick for where the mortise and tenon is going. Come down a little bit farther, just for the mortise and tenon. Then come down to the very bottom. At which point, blue tape comes off. I now use my square. I'll drag it across until I click into where I made that little nick and mark my line. On here, click it in, and I come up a little bit and I mark the center. Click it, mark the center. And this is where a mortise and tenon joint is going to be. Come down, find the next nick, hear it, do the same exact thing. Find the nick, just drag it along, and right there it clicks in, bring it up, and as you can tell, the middle one is a little bit longer, but it's dead on perfect. And then mark out your mortise. And then the end. Right there. It's in the neck. Mark it all the way across. And you can always check everything out. Everything lines up. The advantage is, because I put that nick on the corner, well, I know I have to do the mortise and tenons on this side as well as this side. So I can now just transfer my lines over. Those nicks are already there to help me line everything up, even if I haven't marked my line all the way across. See, that one's easy because I marked that line on both sides. But this right here, I haven't marked all the way up there, but my little tiny nick is right there, easy for me to find. Click, drag, mark the middle. Click, drag, mark the middle. So real quickly, I want to talk about cutting the mortises. There are lots of different ways to do it, and in today's modern age, I think you kind of have to do this quick disclaimer so that people don't say, hey, I don't have the tools you have to do something. Trust me, all you really need to cut a mortise is a chisel. You can use a regular bench chisel, though having a dedicated mortising chisel will make your life a lot easier. What makes it dedicated? Well, it's somewhat trapezoid. It's a little bit thicker on back than on bottom. That way you can steer it as you're going through the mortise if you need to straighten out your line, and it's a lot easier to get out of the mortise if you get jammed in. Plus the fact that the angle of a mortising chisel is typically quite a bit steeper. Though you can put a micro bevel on the end of this and it'll work just fine. I just do find that you can't really leverage a lot on these because the metal is a little bit thin, so you can't bend and break them because you are that strong. That's what all this right here allows you to do, because you can drive it in and just wedge out the chips. And you're going to have to trust me, your first mortise cutting by hand might take you 5 or 10 minutes. But we have 6 mortises per leg. That's 24 for the entire frame. Turn on a movie in your garage on your iPad or the TV or something like that, and by the time you're halfway through that, you're going to have these all done. It's not that hard to do, and there are a lot of videos on how to hand cut mortises. This is a router table though, so I expect a lot of y'all already have routers. So you can just get a plunge cutting style router bit, set up a fence, plunge in, route your thing, pull it out, and then if you do have to have square mortises, chisel out the corner. You can even do that with one of those brace and bits. That's how they did it in the old age. They didn't always cut mortises. Me personally, I'll hand cut a 1/4 inch, 3/8 all day long. They're really quick. You don't even have to use a mallet to do it. You can just use your body pressure. Once I start getting to 1/2 inch sizes or bigger, which these are going to be 1/2 inch or bigger, a lot of times I will turn to some kind of machinery. Just that's what I do. And I actually bought a dedicated machine for making square holes. And that's the technique I'm going to be using, a mortising machine, for the simple reason, I don't know what it is, but it might be since the Domino came out, mortising machines have kind of fallen out of favor. Not as many people are using them. They're kind of a one-use style machines, which means that you can get benchtop models like mine on the used market for just dirt cheap nowadays. It's probably been about 10 years since the Domino came out. That's just kind of taken over. But for stuff like this, I just prefer it because I'm not using a slip tenon in this style. Though if you want to, you can. That's no big deal. I'm using a true Mortise tenon, and being able to drill that square hole is just my preferred way to do it, and it's just super fast and super easy. So that's what I'm going to be demonstrating right now. But before we do that, we need to figure out where we want to place our mortises. So here's my leg. I've got my rounded over show corner to tell me that. So that means the mortise and tenons are going here and here, which I've already laid out where they're going. But I still need to figure out where along this axis I'm going to be placing my mortise. And here are the stiles or rails. I always get those terms mixed up. And basically the thickness of this was just the 2x12 material after I planed it down to make it nice and good looking. I'm not really actually concerned what the real thickness is of this. But whenever I lay them up, you have several options. A lot of people like the flush look, where it's dead on perfect. Looks great. It's not easy to do. I know a lot of professional woodworkers like layering the different parts, because now if for some reason it is not perfectly square, it's a lot less noticeable if it's offset a little bit, and it somewhat gives a little bit of depth to your work. Now I know in the end I'm going to round over this corner right here, so I want to set it off a little bit behind what that round over is, and that little hand plane I use, it does about 1/8 of a round over. So if I take a 1/4 inch bit, I can come over and just have a nice small reveal. Now if I come up in here, I can now say, well, where do I want the tenon on my rail to be? Well, you don't have to have it in the dead center, and there are reasons why you might want to push it closer to the edge. If this corner right here is my show corner, I've got a little round over on that. That's what people are going to see on the outside edge of my piece. That's going to be inside the piece. And I have a tenon that's going to be roughly 1.5 inches. That's a little bit over 1.5 inches. If I put it in the dead center of my board, you can see from both sides, those two tenons are going to meet. So in effect, I'm going to have to shorten them up, otherwise they're just going to bump into each other, or I'll have to put a bevel on either side. If I were to come over here and put it closer to the front, so that that 1/2 inch, that's how wide this little piece is on my dovetail marker, is right about there, I can do the same thing on the other side, and there's little chance that they're going to meet. Or, once again, I could put a slight bevel right there. But I'll get all the glue surface of that 1.5 inches that I want. Plus the fact that if I'm going to be pegging it or draw boring it, the draw bore doesn't have to come all the way through the entire piece. I can just draw bore in, if I come in that far, just draw bore in about twice as far in there, so that the draw bore will have some meat to anchor into. So when you're doing this and you make big legs, and this is the same it's going to be on blanket chest or anything that you're using a frame and panel where you're using a larger leg, oftentimes you'll want to put the tenon closer to your show faces just so you can have more room for the tenon to go into. And I do know a lot of people, after they construct it, right before they glue it up, they will many times cut off this corner just to gain a nicer interior look or a little bit more space. I mentioned that now because now we need to start thinking about the edges of our mortise. And if you're doing it by hand, you're going to want to mark out that face just so you have something to reference against. Though you only need to mark out one side because the other side is going to be taken care of with the tool. If you're doing a router bit, a plunge router, I do suggest you mark out both sides. So you might set up one gauge here and one gauge up there so you don't have to change them up, and leave them set until you finish this entire segment of the project, so in case you have to go back and re-reference it, you can. But that severing the fiber will make the hole for the router a lot better, and there's less likely you'll get a chip that runs out into a part of the wood that you want to keep. Me, because I'm going to be using my mortising machine, it's going to have a fence that I'm going to bump this up into, and then I'm going to drive the square bit down with a drill bit on the inside that will get rid of all the waste, and that's when I'm going to create my square hole. So I'm not going to bother setting this diameter right now with any kind of marking tool, because the fence of my mortising machine is going to take care of that. I just have to set that once, and then I can do the mortises for this side and this side just by flipping the reference face from here to there. A mortising machine really is a simple device, and it does one thing extremely well: making square holes. And they've had mortising machines. Well, there's an argument that this could be one of the first woodworking machines ever. Before they had electric motors, people were just using leverage and their body weight to force a square chisel with something that bored out the center. And some of them were just a chisel that they pressured into the wood and it just sliced it out. This is a pretty generic version of a benchtop size. You have a huge lever that exerts a lot of pressure on the bit as you go through, and on the inside you have effectively a drill press wrapped around that leverage. Now, a lot of new woodworkers look at this and think, oh, it's a drill press. And I guess technically they are, and you can buy attachments for your drill press that will allow you to use the bits that a mortiser does. But I have one of those. Can't even sell it or give it away. I've had it for so long. They just don't work that well. A drill press, it just wasn't meant for the kind of pressure that gets put onto these things. And they're built for that one task. They do it well. So let's take a quick tour, because this is a fairly generic example, and this is one of the first high quality woodworking power tools I ever bought, and I don't use it a lot, but when I do, it's a lifesaver. One of the key features of these machines is what I call chisel. I'm sure it has a specific term, but it's just a four-sided chisel that you can see it's carefully fitted so you can drop a auger. And when I say auger, you know, it has a cutting end on top, but it's not like a regular drill bit that where you can keep sharpening it down, down, down. This spiral design is actually designed to clear away wood, get it out, because as this actually drills ahead of the bit a certain amount, softwood generally more than hardwoods, and then as it drills it out, the points on the end of the chisel come in and push the fibers into this bit so that they can come out and we can get a clean wall. So pretty much before every use, because these things exert a lot of pressure, they dull fairly quickly, but also because it is a joinery, it's a non-show surface on the inside of the wood, nobody actually ever sees it. It doesn't have to be ultimately sharp. I like to polish the outsides on my new bits when I first get them, but pretty much the only sharpening you really need to do, you find on the machine. It seems common nowadays that mortising machines come with this little diamond cone sharpener, and all you do is you give it a good spin around here, try and keep it perpendicular, and that basically sharpens the inside, and you'll get a burr on the outside if you flatten it well. That's perfectly fine. That's going to come off as you use it, and this will be sharp enough for the application. Now these bits come in fairly standard size. You know, you got an 1/8, a 1/4, 3/8, a 1/2 inch. 1/2 inch is as big as I own. I believe you can get bigger, but that's pretty much the most common size you see available. And they come with a special bit, auger bit, as I said. But when you're setting these things up, you had to get the distance of the auger bit in front of the blade just perfectly. Hardwoods typically have a little bit less clearance than softwoods. And how you do that one is because these are two separate parts, they're actually clamped in the device separately. The bit itself goes in your Jacob's chuck, just like any other bit out there. But right below that, you have a clamping device that's going to hold the chisel. And on my particular one, it has these two little feeler gauges. You can separate them out, and what allows you to do that one is you can bump the bit up higher or a little bit lower doing these feeler gauges to get it to the perfect height, whether it is a softwood or a hardwood. And when I say perfect, it's a generalized perfect. So to load the bit, I'm going to put the auger in. It'll pretty much go all the way down. It's not going to come out, but it will slide out here. So I like to put a piece of wood down just in case I accidentally let it go. I don't want to damage it on the metal base of the mortiser. So lift it up. Oh, got to get the Jacob's bit big enough. There we go. Okay, now I'm going to do it for softwood, which means I'm going to use both of these little blocks. I lift up my bit itself as high as it will go. I tighten that in. Then I will push the bit all the way up and tighten my Jacob's chuck. Now the bit itself is perfectly aligned, but to get the clearance, what I do is I loosen up my chisel, remove these two shims, and push that the rest of the way up, and that lowers that bit the perfect amount. The next thing I need to do is set this perfectly square with the fence, so that way you'll make square cuts. I will admit I kind of do this the wrong way. They actually tell you not to register it against a fence. So what I will do is I'll put a small piece of board that I know is parallel. Then I will lower the bit down quite a ways so that it's below right here. So the force is coming from this, not the rotation of that. And then I will bring it, loosen the bit. So now it spins freely. Can y'all see that? Spins freely. I will then bring my fence forward just so it is touching the bit. And when I cannot rotate the bit anymore, I assume it is squared. I would then lift it up as far as it will go, lock it down, and that is now set. The chisel is square with the fence, and the bit is just the perfect distance for a softwood like the pine we're using. Next, I need to set the distance down into the mortise I'm going to be going. Now, there are two ways you can do it. You could put your piece of wood over there and then kind of measure how far down you go. Or, since I know that the board is 2.5 inches, the leg is 2.5 inches thick, I want to go 1.5 inches in. Well, if I just leave an inch gap here, I'm going to be fine. So if I simply lower the bit down to about half that little teeth distance, I can rest assured that I'm going to clear out enough material for 1.5 inches tenon to set up. Then I can reach back here and raise the stop block up to that point and lock that in. And now I cannot go lower than that. My handle will lock down there. So next it's just a matter of setting the fence distance and setting this to the correct height so that whenever I pull the chisel out, it's not going to lift my work up. This will stop it. So with my blank free and clear, but enough so it won't come up, all I got to do is line up the sides with my knife line, and it's simply a matter of lowering it down, drilling a square hole. Move it over, line up the other side. I like to do both sides first and then clear out the middle if there is any middle left. Move down to the next one. After sizing all of these legs, we now have them done, with the exception of maybe adding a taper to the bottom of them. That's optional. Next up, I'm going to go ahead and I'm enjoying playing with the table saw. I normally do most of my joinery by hand. This time I'm going to do it with a table saw just so I can play around with it. But I do have videos out on hand sawing techniques and stuff like that. So if you are doing this strictly by hand tools, visit those. After that, it's just kind of layout. But the next step for me is I'm going to go ahead and get the shorts and the longs all consistent, all accurate for their total length, meaning the interior plus the tenons. And to start that out, I'm going to be going through and I'm going to find the most quarter sawn side of each one of these boards, and that's going to be my show side. And I'm just going to put a little piece of blue tape on that. Next, I'm taking the storyboard that has my legs. I have my short legs and my long legs. And I'm going to use this to try to get the... See, some of these have little blemishes on them. So if I can somehow, on the short side, not include the blemish or include the blemish in the tenon, that's what I want to do. So this being a short one, I am just going to try to figure out the best looking stuff. And then I'm going to make a mark and an X to designate that that's what I'm going to be taking off with my first cut. And then I will use my miter gauge to set the length for both the shorts and the longs, because I only have 2 lengths I have to deal with. For example, the kind of stuff that I am looking at right here, look at this board right there. You see how the grain kind of has a U-ish shape right there? If I can somehow balance so that the crest of the U is in the middle of the board, well, I can actually kind of eyeball that with this story stick and say, okay, that crest right there begins and ends at the same spot. So I need to, if I take off right there and measure this distance there, I'm going to get a nice piece of wood out of that one. That's the kind of stuff I look at when I'm doing this one. This one right here, it kind of ramps up on this side. So if I could bring my story stick farther over here and take that off, by the time it starts ramping up, I'm actually in my tenon, so the grain's going to look straight on this entire piece right here. So I marked off that side. On this one right here, I got a little weird grain going on right there. I don't know what's going on. So I'm going to try and bring it over this side, and what do you know? If I bring it farther enough over, I'm not going to have that show up. Now, I will admit, this is kind of way overkill for a simple... I got crest going on, so let's see if I can get a long piece. Sure can. I mean, we're going way overboard for a simple piece of shop furniture. But I'm picking and choosing the things I want to practice on. I want to get in the habit of constantly looking at my boards and seeking out the best grain as far as structure and cosmetics. And this is just practicing what I want to preach. Now, what kind of stuff don't I care to practice? I'm not going to be sanding this. I mean, that seems like a waste of time. It is shop equipment. Me personally, I probably will not look too hard at refinishing my finishing skills. I haven't even decided if I'm not going to just paint it. That doesn't matter to me. That's not what I'm trying to learn here. I'm trying to practice best skills that'll get me to making better furniture. So in my table saw, I have these little stops. So if I set my fence up for the first one and I want the second one to come over here, well, I can adjust this fence, this stop on this side, right to the end of my story stick, taking all my measurements off of the measurements I did one time. Once again, if I had an error creating my story stick, at least it's going to be consistent through the entire project, so I don't have to worry about it. And now if I cut one side, I can then put the other side on here, and my stop pops out, and I can brace the other end on that side. So all of my sticks for the long will be this size, and then I'll redo it for the shorts. It's amazing how much material we've gone through just to get to this point. I mean, I think a couple of 2x12s. I'll have to go back in the footage to see exactly how much I've used. But if you look at it, the grain is fairly consistent. It's fairly homogeneous. You're about 4 feet away from me right now. I doubt you could tell the grain patterns. It looks consistently throughout, and we did that with careful selection. And I've got it all milled up via the table saw, and I'm going to admit to you, at this point in my woodworking career, if I was making something for a paying customer, I would now turn to hand tools for all the joinery, the sawing and stuff like that. And if that's the approach you want to go, I do have 2 sawing technique videos I would highly recommend, because it's going to give you some tips for getting directly on the line with a lot of cheats and stuff like that. Using gravity to suck up the saw to the line, using your chisel to make it more accurate, all that kind of stuff. But because this isn't a paying project, and I now have a saw that I'm fairly confident I can get accurate, repeatable results with, I'm using this to practice newer techniques to me. So I'm going to be using the table saw for a lot of joinery based upon what I've always been told is the way to go, but when I've tried it on the job site saw, inaccuracies popped up. Hey, shop equipment, as I said, it's time to practice so that you can be confident when your money's on the line. So now comes the time to lay out the joinery. Now, in my design, these all being Mortise and Tenon, they are all the same. In the past, what I probably would have done would have taken my story stick, and if I hadn't cut it down to length, I would have laid out the ends and my shoulder. And I probably would cut the shoulder first and left the length long so that I could get it sized perfectly to each individual mortise, which would have been consistent. Or another way is I could have done exactly what I did right here and cut them all perfectly to length, and then utilize my dovetail marker. Remember, I use 1.5 inches quite a bit, so that's why I made it that way. So I could, in effect, on all my tenons, just bump it up to the edge, mark it, and there we go. A consistent tenon on every single piece, because they're all referencing the same 1.5 inches, or even if it was a little bit off of that, it's consistent throughout the entire project, so we know it will work. And consistency is the name of the game here. So what I've got is I've got a little magnetic brace that's about 2 inches from my fence, and I'm using the fence simply to kind of back it up because this magnet isn't the strongest. And I've set that distance from here to the other side of my blade to be the perfect 1.5 inch. The hard part for me is setting the depth for 2 main reasons. One of them is I have a general purpose blade. It's not a flat bottom blade. So I get those bad ears on either side of my cut. So I've got to set the depth to the tips of those bad ears. Second was when milling these, I was never really concerned with the thickness because I do a lot of relative measurements. And these, I just made them consistent, running them through the thickness planer so that they're all the same. And they all turned out to be roughly 1 and a tad bit over 3/8 of an inch thick. I do know that the tenons I made were using the 1/2 inch hollow chisel mortising bit, so I have my 1/2 inch little thing right here, and I can see that it fits in pretty well. A little glue and it's going to work great on all of them. So if I can make my tenon maybe, you know, a 1/64 thicker than this, it'll fit even snugger and I can get a little compression factor on there. So I need to basically, to figure out the tenon size, I could measure up a little bit one way, cut one side, and then measure over that distance, or I could put, and that would offset the tenon one side or the other, and we talked about that earlier. Or I could just put the tenon in the dead middle, which is how I designed my layout, is I want in the dead middle. So if I take away 1/2 inch out of 1 3/8, that gives me about 7/8. So I need to come up half of 7/8, which you double the denominator, that's 7/16 from each side. The easiest way I know to do that, so I'll set my gauge up to 7/16. lock that down. I use this now to set up my marking gauge, getting that just dead on perfect, and then grabbing one of the pieces, making sure here's my show face so that the tenon is going this direction. I will go ahead and mark the end from both sides, just as if I was hand cutting it. Then verify that that'll fit my tenon. Hey, that's pretty dead on perfect. Then I'm going to use this to set up my table saw. What I end up doing is sneaking up on that line. I will kind of eyeball it so it's right underneath it with the gauge, and then I'll start nibbling it up on the very end, trying to line it up so the end of this side right here is right on one of those peaks. And just keep making that cut until I basically take the line, just raising it up a little bit more each time. And when I get it right, I should be able to come over and place that little nub right in my joint. Yep, that'll work. So my first step is to cut the length on all of these. Now we need to cut the short side of our tenons. Now I don't place much importance on the short side as getting it as accurate as the long side, because the long side is where most of your glue adhesion is going to be, because that's long grain to long grain when it goes into the mortise and tenon. The short side is actually long grain against the end grain on the leg, so there's not as much glue bond there. The key thing is just get it close, in my opinion. And if you're a little bit loose on that side, it will allow you to adjust the rail up and down a tad bit to get it perfectly aligned. The key thing is the long side just has to be perfect. Now to do the short side, all I'm going to do is use that little brass thing that we use when we set up our story guide, because that's the setting. So, I mean, how many times have you actually seen me pull out a ruler in this project? It's not that often. Tad bit proud, lock it down, and now cut them off. Now my preferred method of cutting the tenon cheeks has always been the bandsaw. I actually like the slightly rougher finish because it will compress a little bit easier, so it seems I can get a tighter fit that way. But I do plan on making a tenoning jig sometime for my table saw to experiment with that out. So the biggest issue with using your bandsaw to cut those cheeks though is getting the bed absolutely perpendicular to the blade. Mine is extremely finicky because I don't have any fine adjustment dials. You kind of just have to loosen the bed up from underneath and tap it. There is a set screw over here which supposedly I should be able to kind of lock it down, but you notice the way the bed is set up, it can twist on you. So it's a bit of trial and error, and I have to reset it every single time I cut tenons. But normally I'm never cutting one or two. I'm cutting, 24 to 30 of them. So it's not that big a deal to spend a couple minutes setting it up. Now setting up the distance of your blade from your fence couldn't be simpler, because remember when we did those test cuts to get the tenon to fit just perfectly on the table saw? We still have those. you can actually just kind of rest that up against the blade and then bring your fence over, and everything should work out. Be sure to test it in both directions. Fits nicely. Now, I do like to make a test cut. So what I will do is I'm going to come in a little bit on both sides and then cut off the side with that bandsaw blade and then go make sure it's going to fit into my mortise. Settings are good. Now, some things I bet some of y'all would notice. I went a lot slower on the bandsaw than you normally would. I have a fairly aggressive tooth over there. I only have one blade. That's 3 TPI, and I use that for my turning and stuff like that. Going slower didn't allow the bandsaw to deflect very much. It wouldn't wander as much. It wasn't taking as big enough bite, so the force wasn't acting against it. So I got a flatter, more accurate face. Also, I just progressed until the piece popped off, which means I was a table saw kerf away from denting the sides, so it wouldn't show. And even if I had a little bit in there, I could take care of that with a chisel. Now, if I was a little bit off on my table saw cut, where I progressed a little bit too far down, no big deal. The glue surface comes from what the cheek we took off on the bandsaw. So this was actually more critical than the table saw. It's just we could use the table saw as a setup guide for the bandsaw. All I have to do left is to cut off the short ends, and as I said earlier, I'm not too concerned with those ultimate accuracy, and I will just use a little brass thing that I did to set up my table saw and take those off. So I'll do that off camera. Now, I don't care how good your machining skills are, you are always going to end up with some stuff that has little bits of schmutches on it or little things you need to clean up. And that's the same in the mortises at the same time. So spend 5 minutes or so, get a single point reference, then just clean up all your joints. It's where a nice sharp chisel comes into effect. Can't finish this section without at least dry fitting it, right? Well, we're going to have to dry fit it to get measurements for the other parts anyway, so might as well do it now. I will tell you this, the dry fitting showed me I made a mistake. I don't know why I put these two in here, these two holes. I guess I assumed I was going to do another one of these stretches, but I'd always planned on just doing a shelf right here. But it'll give me a chance to show you how to fix repairs, or fix mistakes. So there we go, the frame of our frame and panel design. Fairly simple when you step back and look at it. And there was nothing about this that was overly complex. We were basically making square holes and then straight cuts. Now, if you wanted to really challenge yourself, and I think this would be really cool, is maybe tapering these out to the sides or even a double taper, which all that would necessitate is figuring out the angles and lengths right there. That'd be a great challenge if you're a little bit more experienced and want to try that out for maybe a future table design or anything like that. But what we've done right here is the basics of all table making, a lot of chair making, you wanted to make a blanket chest, all that kind of stuff, here you go. And this is the kind of joinery that will last generations. It will take a lot of abuse. I mean, you could even just peg these corners right now and it would be a solid build without any glue. That's how they did it for centuries. Glue will just make it that much better. And it's a lot longer lasting, better built, and something you'll be more proud of than a simple cabinet assembled with plywood and pocket hole screws. We'll come back for the next segment where we're going to start on making the panels for our frame and panel design.